Okay, here's warm up 9.2. I've got some triangles. I'm going to find some missing sides, and last problem I do the area. I'm also going to use simple radical form. Okay, so this first problem, I've got 3 and 5 as two of my sides. So sometimes people look at this and say, oh, it's a 3, 4, 5 triangle, and that's reasonable. But if you think about it, if you put 4 up here, if this x was a 4, then that's the hypotenuse, and the hypotenuse is the longest side, and 4 is not bigger than 5, so that doesn't work. In a 3, 4, 5 triangle, the 5 would have to be the hypotenuse, and here the 5 is one of the legs. Okay, so that means I'm going to use the Pythagorean theorem. So Pythagorean theorem, a squared plus b squared equals c squared. Okay, these are going to be my legs, the a and the b, and the c is the hypotenuse. Okay, so the legs are the ones that are touching the right angle, right? So this is a leg, and this is a leg, and my hypotenuse, 2 ways to find it. It's the longest side, but sometimes it's hard to tell which the longest side is, but it's always across from the right angle as well, okay? So setting this up with the Pythagorean theorem, 3 and 5 are a and b, and they're interchangeable. So if you said 5 squared plus 3 squared, that's fine, because 3 plus 5 is the same as 5 plus 3. Same thing with their squares. And then, but the c, the part that's isolated, has to be the hypotenuse. That's really important. So my x goes there. Okay? So then I'm going to do the squaring. 3 squared is 9. 5 squared is 25. Okay? And next I'll do the arithmetic here on the left. I'll add those like terms. That's going to be 34. I've got 34 equals x squared. Okay? So now to solve for x, I've got x squared, but I want x itself. What I'm going to do is take the square root of both sides of the equation, okay? And technically, algebraically, when you take the square root of both sides of an equation, you'd have a positive and negative root. You put a little plus minus out here. But I'm not going to do that because this hypotenuse can't be negative. It's got to be have a positive length. So I'm only using the positive root here. So then the square root of 34, well, a square and a square root undo each other, so that's what x is going to equal. Okay, and I've got my answer. I could turn that into a decimal. It's not in a perfect square, but it's not in simple radical form. Okay, so simple radical form, there's lots of different ways you can do simple radical form. The way I teach it, I think of a multiplication problem where the answer is 34. So since it's an even number, I know I can divide it by 2, so that would be 2 times 17. Okay? And then I'd be looking for twins. Well, I don't see any twins here. I don't have twin 2s or twin 17s. And then I think, well, can I break these pieces down? I can't really break down 2. I can only do 1 times 2. Same with 17. It's a prime number, so 1 times 17. So, hey, there's no twins there. So that means that this is in simple radical form already, root 34. Okay, but sometimes we can go a step further. So let's see what happens on the next one. Okay, so the hypotenuse, again, is going to be right here. It's really important that you're able to identify which is the hypotenuse. So Pythagorean theorem again. You can do this with any right triangle. If you didn't have a right triangle, you wouldn't have a hypotenuse, so this wouldn't work. Okay. My legs are going to be x and 6. And again, you could switch the order. It could be 6 squared plus x squared. It doesn't matter which one's a and b, but it definitely matters. The 14 is the c, and that's going to be the isolated one over there. Okay. So I'm going to do the squaring on both sides. So 6 squared is 36, and 14 squared, 14 times itself, is 196. Okay? So I want to get the x by itself. Next step, I'm going to subtract 36 from both sides. Okay, and I'm going to get 160 over here. All right. Next step, I want to find out what x equals, so I'm going to take the square root of both sides, and it's going to look like this. Okay, so I got it down to that, but let's go simple radical form. So I'm going to start breaking this up, looking for twins. So first thing I'm thinking, it ends in a 0, so 16 times 10. And there's different ways you could break this up. It doesn't matter if you broke this up in a different way. Ultimately, you should find twins, and we should end up at the same place. I don't see any twins yet, so I'm going to keep going. 16 is 4 times 4. Okay, and then 10 I could break into 2 times 5. Now I could keep breaking up the 4s, and there's nothing wrong with that. Each one of them would be 2 times 2. But I already found some twins. I can see some twins now. I've got twin 4s. Okay? So if you think about this as a jail, they make a break for it. One of the 4s distracts the guards and gets taken away. The other 4 gets out, though. So this 4 is going to get out. The 2 and the 5 don't have twins, so they can't escape from the jail, and they're just stuck in there. And if they're stuck in there, multiply them together. So this is going to be 4 root 10. So 4 root 10 is equivalent to the square root of 160, but this is in simple radical form. Okay? All right. So in this problem, in this right triangle, we've got 2 congruent sides, so we're going to be looking at that pretty soon. But let's just solve for x here using the Pythagorean theorem. Okay, so my legs would be the 3's, and the hypotenuse is going to be the x. So I've got 9 plus 9 equals x squared. 9 plus 9 is 18. Okay, then I'm taking the square root of both sides. And then, again, I'm putting this in simple radical form. So I'm starting to break up, thinking, okay, that's 2 times 9. And then no twins yet, but the 9 I can break into 2 times 3 times 3. I'm running out of space here. So I'm going to have to go to the right here. Okay? So, hey, those twins make a break for it. One gets caught, distracting the guards and taken away. The other 3, though, gets out. And so I'll have a 3 on the outside, and then a 2 is just going to be trapped there. So x is going to equal 3 root 2. Interesting. When our legs are both 3, the hypotenuse comes out to 3 root 2. Okay, so we're going to be looking at that in more depth soon. Okay, number 4, let's find the area. Use simple radical form if necessary. Okay, so hey, a triangle, I've got my area formula for a triangle. For a rectangle, it would be base times height, but for a triangle, it's going to be 1/2 of base times height. Okay, or some people say base times height divided by 2. That will work as well. Okay, so the base and height have to be perpendicular to each other. Okay, so that means I need a perpendicular pair. So in this diagram, I can only really use those 2. Okay, so 8 is going to be my base. But I still need to find that height. Okay, and I don't know, I mean, I could write h in, but I need to figure out what h is in order to get the area of this triangle. So here's the deal. If you look at these 2 triangles, these 2 smaller triangles, they're actually going to be congruent. If you go way back to, I don't know, chapter 5, I think, these are congruent by the reflexive property. That segment's congruent to itself. Hey, then these triangles are congruent by HL. I have a leg and a hypotenuse in both of these triangles. So these triangles are congruent, which means all the corresponding parts are congruent. And what I'm getting at here is that these 2 pieces are congruent. So that means that 8 is cut in half. So I've got 4 and 4. Okay? Now the reason I wanted to do that is because now I can use one of those triangles to find h. Okay, so I can think, okay, 4 and h would be my legs, my A and my B. So 8, well, I'll put h for A, and I'll put 4 for B. The C would be 5. Okay, and you might know where we're going with this, and if you notice that, that's okay. 4 squared is 16. 5 squared is 25. Let's subtract 16. Trying to isolate the h here, so that gives me h squared is 9. Now I'll take the square root of both sides, and h is going to equal 3. Okay, this is a 3, 4, 5 triangle. So if you recognize that it's a 3, 4, 5, that's fine. You could just say it's going to be 3. It's a Pythagorean triple, is what you can call it. Okay, so my height is 3. I did all that work to find this, and now I can get the area of this triangle. Okay, so let's see, 1/2 times 8. That's just half of 8. That's going to be 4. And then 4 times 3 is 12. And I need to put my units in here since I have them. So I'm talking about centimeters, but with area, it's going to be square centimeters. And there is my area. And that is the end of the warm-up, and I'll see you next time.